And we're back for part 2 of variation of parameters, section 5.5b. So let me slide this up here so we can talk about a specific example of method of variation of parameters. As we just talked about here, we have a second order differential equation with constant coefficients and he's linear. But notice this nasty non-homogeneous piece that we played with his derivatives a few minutes ago. So let's solve this guy. And as always, step 1 is setting up and solving the homogeneous system. So y double prime minus 2y prime plus y equals 0. If we do that, we notice he's second order linear constant coefficient. So we expect e to the rx to be our solution. And so if we put that in, we end up with the characteristic equation of r squared minus 2r plus 1 equals 0, which we can then solve as, well, solve by factoring. Looks like r minus 1 times r minus 1 is 0. So r equals 1 and 1. So our two solutions are y sub c equals c1 e to the 1x. Oh, but we have some duplication. So c2 x e to the 2x. Oh, sorry, e to the x, e to the 1x. So because of the duplication, we have c1 e to the x plus c2 x e to the x. Okay, and we're going to call this guy, whoever we choose to be the first part, we're going to call him y sub 1. And this second guy, we're going to call y sub 2. Okay, so in other words, y sub 1 equals e to the x, and y sub 2 is equal to x e to the x. Now, in a nod sort of like the method of undetermined coefficients, we're going to say that, hey, our particular solution is probably going to be kind of like this, but multiplied by some, not constant, but some function now of these guys. So we'll call those undetermined functions yet u sub 1 of x and u sub 2 of x that will multiply onto y1 and y2 respectively. And we're going to stop writing the of x and just use some shorthand notation and just say y sub p equals u1 times y1 plus u2 times y2, understanding that these are each functions of x. Okay. Now, notice that the u1 and u2 are functions, not just constants. Okay. So since we're going to be needing a second derivative here, let's take our y sub p and take his first derivative. So y sub p is equal to, or y sub p prime is equal to u sub 1 e to the x plus u1 prime e to the x. If we, I think I need to remember that y sub p is going to be u sub 1 e to the x plus u sub 2 times x e to the x. And remembering that u sub 1 and u sub 2 are functions, not necessarily constants. So we need a product rule here. We're also going to need a product rule here. So we'll do the first times the derivative of the second. So we'll have, the second actually is going to involve the product rule as well. So x times e to the x plus e to the x times the derivative of x with respect to x, which is 1, plus then u2 prime times x e to the x. Okay. And what I'm going to do is I'm going to take the terms that involve u1 prime and u2 prime, and I have some flexibility here, u1 prime e to the x plus u2 prime x e to the x, because I have some chosen the two u functions here. I'm going to set those equal to 0 for now. Okay, so I'm going to star this because we're going to come back to that later. That means then that y sub p prime is equal to u1 e to the x plus u2 times x e to the x plus e to the x. Okay. Next up, we're going to take the second derivative of y sub p. So we need y sub p double prime So again, we'll need a product rule, u sub 1 times the derivative of e to the x, but he uses his own derivative, plus e to the x times u1 prime, plus u sub 2 times the derivative of this. We'll have x e to the x plus e to the x plus e to the x, so that's x e to the x plus 2 e to the x's, and plus u2 prime times x e to the x plus e to the x. Okay, so now we're going to remember our original differential equation was y double prime minus 2y prime plus y equals e to the x over x squared plus 1. Oops, let me move that up so you can see that. And what we're trying to do is pick up the non-homogeneous piece, so let's take those guys, the y sub p's. Therefore, y sub p double prime is u sub 1 e to the x plus, I'll write the u1 prime e to the x, okay, plus u2 times x e to the x plus 2 e to the x plus u2 prime times x e to the x plus e to the x. So that was yp double prime. Let's go ahead and do minus 2y sub p prime, which would be this guy. So minus 2 u sub 1 e to the x minus 2 u sub 2 times x e to the x plus e to the x. Okay. And let's go back and add our original y sub p using our u sub 1 times y1 and u sub 2 times y2. And let's do that in another color. How about u sub 1 e to the x plus u sub 2 e to the x. Okay. And if we add up the whole left-hand side here, it should equal this guy. So if we add up all of this whole left-hand side, it should equal the same thing as well, because each of these little pieces is equal. But let's see what wonderful things happen here. When I do u1 e to the x minus 2u1 e to the x plus u1 e to the x, those all add up to be 0. Okay, and we still have plus u1 prime e to the x. Let's see what happens here. We're going to have u2 times 2 e to the x minus 2u2 e to the x. So this piece and this piece will go away. Oh, and I accidentally forgot somebody. I need an x e to the x for my y sub p. And, oh, let's check this out. u2 x e to the x plus u2 x e to the x minus 2u2 x e to the x. These terms will also make 0. And so what we're left with here is u2 prime times x e to the x plus e to the x. And if that's true, then this left-hand side equaling this must mean that this all adds up to that. Or in other words, after a long story short, u1 prime e to the x plus u2 prime times x e to the x plus e to the x should equal e to the x over x squared plus 1. Let me pause right there, and then we'll pick up on the top of the next page for our next video.